Okay. In factorial, two things are important. First, condition that ends the recursion. Second, else condition which continues the recursion. Right? This is the condition which ends the recursion, right? Because the stack has to throw some value, and this is the condition which will continue, right? So here, when I say fact 3, yeah, so when I say fact 3, so on the stack, so let's say this is your stack. So stack, does anybody knows how does stack work? Yes. Last in, first out. Last in, first out. Q is first in, first out. Q. There are two data structures, stack and heap. Stack you can actually compare with anything. Stack of books, stack of plates. Let's say you have a stack of plates, right? So which plate will you pick? Let's say when you are adding a plate, where will you add? You will add to the top of the stack, right? And if you want to remove the plate, where will you remove you will remove from the top of the stack. So top of the stack is always the element which is used to insert also and to delete also. Okay, so there is one point of insertion and one point of deletion. It's the same thing, and that's the last element which is added, right? Last element which is added, on the top of the element the new will be inserted, and the last element would be the first element to be deleted. So that is called stack. Q is similar to a queue. If you compare it with the line, the first come first. Whoever comes first will be served first, right? So the first element added would be the first element deleted. Okay. So if you try to put it in a Word document, so let me create a Word document. I don't want to get into this. So once I'll do the collections, I'll explain all the data structures. So this is your stack, and just a second. Right, so this is your stack. So what it means, like here your element would be added, and it would be pushed down every time. So just like when you put, let's say you clean some plates, you put the first plate at the bottom, and then you put the second plate on top of it, third plate on top of it. It's a stack, right? And when you let's say you want to put something in a plate, so which you want to take a plate out, you don't take a plate from the bottom or from the between. From where do you take the plate? At the top, right? So this is the topmost element is called the top of the stack, and this is the element where you pop. So we call push. There are two operations for the stack, push and pop. Push and pop. So push means insert new element at top of the stack, and pop means delete the element from top of the stack. So let's say I want to delete the third element. I want to have an access to the third element. I cannot have the access to the third element in the stack unless and until I popped out the first two. first two elements. To reach the third element, I have to first pop this, then pop this. Let me explain the factorial in Paint. This is actually a better way. So this is your stack. When you write factorial 3, right? So it goes here at the bottom. Factorial 3. Here n is equal to 3, right? So factorial 3, what is the value of the factorial 3? So here it goes to the else condition and it will say n into factorial of n minus 1, right? So what is the value here? Factorial, this is equal to 3 multiplied by factorial of 2. So factorial, the next factorial would be added onto the stack because factorial 2 will be called, right? After factorial 3, factorial 2 will be called and this would be on top of the stack. This would be factorial 2 would be called. What is factorial 2? Now and again when it says factorial 2, so again it will go to this return statement and it would say 2 into factorial of 2 minus 1. So this is actually, this is calculated as 2 multiplied by factorial of 1, right? Again factorial of 1 will be called. Factorial of 1 would be called. 1 would be, n would be now 1. When n is 1, what I have to return? 1. So here on top of the stack, it will be now factorial 1. This would be factorial of 1, which is equal to 1. Now this would be popped out. That means this we have got the value. When you return, right? Till now it is still on the, everything is still on the stack. The value is not returned. Now when it say return 1, now the exact value, exact integer is returned. So this would be popped out, this value will be popped out of the stack. So this would be popped out. This would be erased. So now on the top of the stack we have factorial 2 is equal to 2 multiplied by value of factorial 1. What is the value of factorial 1? So this would be replaced by 1. Okay. When it replaced by 1, this is a regular value. This would be again popped out, right? It is returned. So it is returning 2. So this would again be popped out. What is left? Factorial 3. 3 multiplied by factorial 2. What is the last value of factorial 2? 2. Right? So 3 multiplied by 2. So now it's a integer value. This would be popped out. So your last returned value would be 6. 3 multiplied by 2 equal to 6. I'm able to explain recursion. My teacher would have been very proud of me. Is it clear? Right? So in recursion, what happens is, why do we do recursion? We try to avoid, we can do the same thing using loops, right? But here, if you notice how many integers take place. Just n was a number, and there was just 3 elements which are pushed onto the stack, right? When you do a loop, right, you are creating an I, you are creating the computation inside that loop. Like it's not that performance effective when you do it in loops, because here it is taking the concise space. In a stack only, it is doing the entire thing. The entire logic is in the stack. The function's entire logic is in the stack, in just one element in the stack. There in loop, you have to create, some temporary variables probably that will take a lot of memory, and loop running takes a lot of memory, right? So running a loop takes definitely is not a very effective way to compute a program. So it's always better to do a computation in a line rather than doing in a loop. Okay, because when you create a loop, it will create a separate memory area for the temporary variable that you are using, right? And then it will keep on incrementing that. So it will, with every loop there is a condition. So with every loop it is checking the condition also, and then it is incrementing. So it is a lot of computation. So it's always, the recursion is one of the most effective way of doing computation. But not every problem can be done using recursion. So factorial, just like when you do the repeated steps with different value. So here what I'm doing, 3 multiplied by 2 multiplied by 1. So I'm doing the repeated steps with just different values. The numbers are changing. How the number is changing? So that we have defined in n into n minus 1. It could be n plus 1. It could be, if any series, let's say you want to calculate. So you can do it using recursion. So try to do, this is a factorial, try to do another program. Add find the sum of first n integers using recursion. First n integers, like 1 to n, and not only you can say the series. You can find, let's say I want to find this series 1 plus n plus let's say n square n raised to power n raised to power 2 plus n raised to power 3, so on and so forth. So this also series, this is a series. Generally for calculating the series we can use recursion. Yes, Fibonacci can also be used, can be done using recursion. Please, but don't ask me to write the code. I don't know how to do it.
Exceptions. What are different types of exceptions? And what are the conditions in which these exceptions occur, right? So what are exceptions? Exceptions are the error conditions which does not allow the program to run in the expected flow. What does that mean? That means that sometimes what happens, I've written some certain logic, certain program, but my output, like the program does not run in entirety. It stops in between. So why it is that happens? There could be many reasons for that. So we have two types of exceptions. We have checked exception and unchecked exceptions. Before coming to checked and unchecked exceptions, let me tell you what different types of error conditions could be there. First thing is, there are certain conditions which are caused by programming error, or we call it logical error, right? So logical error. Second could be the error which is out of scope of the program. What does that mean? For example, I'll give you an example. Let's say I have written a program to read a file and read some data from a file and display it on the screen, right? Now the program runs, the logic is fine, like I've used the correct API and everything, but somebody deletes that file. Or let's say not the deletion of file, when you are trying to read from the hard disk crashes, right? Now your program cannot correct the hard disk, right? So if this hard disk crashes, or let's say your program, the memory in your computer system is eaten by some other application, so there is not enough memory to run the program. So it's an error which is halting the current flow of execution, but it is not the responsibility of the program to, and it's not the program is not capable to recover from that error, right? So there's nothing to do with the program. It is outside the scope of the program, right? Then there are third types of errors, which we call them, you can say, recoverable errors. In recoverable errors means just like I told you, gave you an example. I'm writing a program to read from a file, and somebody by mistake that the file is being deleted, right? So the program logic is perfectly fine. If somebody keeps that file again at the same place, the program will run fine, right? Similarly, let's say I ask you to enter your age. By mistake, you write it in negative. If I prompt you that it is a negative number, please add a positive number, my program will run fine, right? So my program can recover from the error which the program has produced, right? And continue with the regular flow. So these are called recoverable errors, right? Then there are some the worst kind of error is logical error. Logical error means someone asked me to compute the total of the fees collected from the last batch, and I computed the fees from the previous, let's say 2012. This is a logical error. You are like the entire logic of adding the fees is wrong. Instead of, let's say, plus, I put multiplication. The logic is wrong. No, we cannot correct. For correcting that, we have to correct the code. We can't correct. When I am correcting the code, that is not, the program is not recovering. The program logic is changing. When I say recoverable errors, that means we are not changing the code of the program, right? So it is generally due to bad user input. Bad user input. Just like I said, right, you are putting a negative number for the age. It's a bad user input. You are asking the user to input something. The same kind of thing, let's say you are typing email ID and you forgot to put @ right? The program logic is fine, but program logic can tell you it will not go to the next step unless and until you enter a right email ID. So it is the program is recoverable. You don't have to change the logic. What you will change the input, right? So all these three types of errors, JVM has its own way to tell the programmer that these three different types of errors have occurred. Okay. The first is, I should put this in the end. The first is unchecked exceptions, or we also call them runtime exceptions. The second is checked exceptions, and we also call them compile time exceptions. And the third is in Java language we call errors. So in Java, error is different from exception. Error is a condition which is out of the scope of the program. The program has nothing to do with this, right? Only the exceptions are, and how the JVM tells you that it is there is an error. It creates an object. So exception is nothing but it is an object that is created by JVM to tell what error has been there in the program and what is the cause of the error. Okay, so exception is basically a class. When I say it creates an object of exception, what does it mean? If there has to be a class, the exception is a class. The parent class of exception is throwable. So throwable is the super class of all the exceptions plus error. So error is also a class. So error is this error and exceptions is these two exceptions. So runtime exception is the subclass of exception. Runtime exception. So let me show you the diagram for conditions that your program encounters. While mild, because the stringent error conditions, then it will not throw exception, then it will throw error, right? So if it is out, just like, so you, what are your common errors? No. So these are the three, JVM throws three types of errors. First is either it throws runtime exception, compile time exception or error. Okay. So runtime exception or compile time exception are, they are objects of exception class. Okay. Error is basically the object of error class. And the super class for these two is throwable. I can show you the chart of the exception. So the super class is throwable class. And then we have error and exception. If you see in error, we have virtual machine error, AWT error, stack overflow, out of memory error. These errors are beyond the scope of the program. The program cannot recover from these errors. If these error occurs, your program cannot continue in any condition, right? So what does that mean? The programmer cannot write any logic to recover from that. Because as a programmer, can I write a logic to correct my hard disk or increase the memory of the program? No, I cannot do that, right? So it is beyond the scope of my program. Then we have exceptions, which are mild error conditions. There are two types of exceptions. We have compile time and runtime exception, right? So runtime exception basically is an object of exception. So you don't compare it with, IO exception is a compile time exception. So we have other exceptions also, like SQL exceptions. I'll give you some compile time exceptions. This is not an exception. It's not an exception. Exception means the object is created by the JVM to tell you that this has, that is, the program runs fine, right? Although it is running infinite loop and it is eating your memory, but it is, the logic might be bad, but it's not an exception. Okay, so let's write a small program. Let's write a small program to create an exception. Let's say to create a package, new package com.wp qa.exception, and here I'm creating a class. Okay, so I'm writing a small method, say public void divide by n, right? So, and I'm passing an integer n, and this program, say it's returning a double, and it's supposed to return 3.14 divided by n, right? This is a simple program which takes an integer as an argument and it returns 3.14 is pi, right? Pi by n. For some reason, let's say it is returning this. Okay. Now, let's try to test this. And here I'm creating how will I do? I will create an object of my exception. You can use control space to write the rest. So I'm using control space. So every time you write something, if that class or that keyword is already defined, so just use control space, automatically it will be filled up. And say divide by n. And here I'm passing 100. And say double RET is equal to sys and sys out RET. Then what does it return? Double. Right? So let me run this. So it is giving me some value. Okay. Now let's say instead of 100, I am writing here 0. And actually this is a bad thing. Let's say I'm writing here 45. I'll tell you why it is not throwing the exception. Now it will throw the exception. If you see this, what happens? I'm trying to divide a number by 0. Division by 0 is not defined, right? So there are certain error conditions already defined in the java.lang package. For example, if you see here, it says java.lang.arithmetic exception. So arithmetic exception is basically a class which is a subclass of exception, just like this. So if you see this, exception, runtime exception, arithmetic exception. So arithmetic exception is a subclass of runtime exception, right? So it is already there in java.lang, and anything which is any error condition related to arithmetic, it creates object of arithmetic exception. Okay. Now I want to actually show you another important thing, how to, when you run your program, a lot of times your program will throw such kind of exception. So let's try to read the exception. We always read the exception. This is called exception trace, stack trace. Just like the stack trace, stack everybody knows, right? What is a stack? So in exception, what happens? your main method is the entry point. So your main method would always be at the bottom. If you see this is the package name, this is the class name, and this is the method. From here the flow generated, and in this class at which line the exception was thrown. So it was thrown at 14th line. You see this 14th line. Click on this. So it will tell you at this line the exception thrown, and the program stopped at this line. It did not go beyond this line. If I tried, if you see this statement system.out.println RET is not printed, right? It does not print. It stops. Now go to the next line. This method is calling divide by n, right? Where is divide by n? My exception basic divide by n method, and click on this. In the 6th line of this particular class, right? So here we have just two methods, one calling another. There could be n number of methods, one calling another, and then it might be calling another. There would be different classes which should be called. So the stack trace gives you the entry point until it reaches the end. That finally at which statement the exception occurs. So at the topmost one would be the one which you should be looking at. Okay. Sometimes in WebDriver script, the middle classes would be written by you, and the topmost classes are defined by WebDriver API. You don't have access to that. You might not be having the source code for that. But the middle classes is written by you, so you can actually correct the code there. So this is a runtime exception. So runtime exception is occurred by what? Logical errors, programming errors, right? So who is responsible for this? Programmer is responsible for it, right? So what does it mean? When I am trying to divide by n, the programmer should write a logic something like this: if n is not equal to, or is, you can say, if n is equal to 0, this out say division by 0 not possible, and it should return, say, return 0.0, right? So I'm not going ahead. So I'm throwing an error like this. So this is programmer. So as a programmer, I need to check all the runtime exceptions. It's my responsibility, and this generally occurs with the logical errors. For example, another thing I can give you another example. This is an example of arithmetic exception. No, this is for condition, right? If n is equal to 0, then return 0.0. If it is not 0, then return 45.10. Then only I want to divide it by n. Otherwise, I don't want to divide, right? And then let's say another very common exception is null pointer exception. Let's say I'm writing a program. Find length, and I'm passing a string. And the length should be int. Right? And I'm writing here len is equal to str dot length. Let's try to run this program. So give me the test cases for this. Give me the test cases. How will I test? Ex dot is find length. So how would I test? I'll write here some text, some string I'm typing here, right? And say int n is equal to right. It is giving me 12, right? Now, instead of this, I am passing, it's an object, right? String is an object, and I'm passing null. It again throws me an exception. So, don't think that I am passing here null. This find len in your program is a 1000-line in code of program. The output of one method is passed as an input to another method, right? So you don't know what exactly the code is, what exactly the object is being passed. It can be null, it can be any other value. Right? So as a programmer, it's my responsibility to ensure, and as a tester, you also need to test the code. This is unit testing. When you do unit testing, you have to figure out, for some reason, let's say the null object is the application crashing. Exception means your application crash. Okay? What does exception mean? That application is not able to move to the next page. Your application crashes. So even in fact, in a lot of online applications, I will give you one example. This is mortgagecalculator.org, and if you see here, some exception occurred. Your application crashed. See how does it look? Right? This is really bad. Okay. So you don't want the user to know that that your application crashed. Probably you should have indicated, the best way to write is you should have your program should have known that this is not a valid number, valid digit, and it should have prompted that please enter a valid value of this mortgage, home value. This is not valid. Only digits are allowed. Only positive integers are allowed. Something like that, right? So handling the exception is, anyway exceptions might occur. So you don't have the, you can say, you cannot restrain a user to enter anything, right? So, but your program should be smart enough to catch whatever it is, exception has occurred, and give an appropriate message to the input, because this is, so what happens, there is a mechanism called try catch. Try catch means there is a block called try catch block. What I can do, I can put this into a try catch block. Try catch block. What does try catch block mean? Try catch means if any exception occurs in this particular block, it will be caught here. So what I'm expecting here, I'm expecting a null pointer exception. So I can write here null pointer exception E. If this null pointer exception occurs, that means if this object is created by JVM, then go to this particular block of code. That means I can write here this out, the string is null. Okay, and in real world, what happens? Generally, you put these kind of statements in your log file, right? Because the person who is using the application may not be able to see the code. but he can see the log file, right? So you want to see the log file, so you want to print this kind of a statement or error message in the log file. Instead of printing it on the out, you will be printing onto a log file. So that's a different story how we do that. We'll do it in next class. Okay. So this is called try and catch block. In try block means now what happens if you put in catch block, if let's say you have a statement outside this, the program ends nicely. Now let's try to run this again. Do you see this? The string is null, the program ends nicely. It continues to the next step. It does not stop in between. So when you catch the exception, the program does not end, halts there. You do a corrective measurement, either a corrective measurement or some kind of logging or messages if you cannot recover from that, and you continue with the next step, right? So the person who wrote this particular application forgot to catch the exception. He should have caught the exception and written the message, something like that this is an invalid input. Did you get this? So we have all these are runtime exceptions. Runtime exception means first thing is they are caused by the programming errors or logical errors in the program, right? Your compiler will not prompt you that this is, because compiler cannot check the logical errors. Compiler can only check the syntactical errors, right? So compiler will not prompt you for this because it can happen because of any bad flow of data or bad programming or anything like that. Runtime exception. Runtime exception. Runtime exception or logical exception that occurs due to the bad programming errors or logical errors in the program. And it's the programmer's responsibility to catch the exception and give the appropriate message or log the details of that exception. That is also a runtime exception. No, page is not. Timeout exception if that selenium occurs, then you put wait, and if that then you put wait. Let's say you put a wait of 4 seconds. In 4 seconds, if that element does not appear, then it throws a timeout exception. It's a runtime exception only. Timeout exception is the object that is being created. That timeout exception is defined in the Selenium API. It's not java.lang exception, it's the Selenium exception. Okay? So all this here, null pointer exception, this is a java.lang exception. All these exceptions are classes, right? So some classes are defined by java.lang, like null pointer exception, SQL exception, arithmetic exception, negative integer, negative index, array index bound, negative array index, that's also a java.lang exception. You can define your own exceptions. I will come to that part also after the break. No, that is not a syntactical error. See, syntactical errors are not exceptions. When there are syntactical errors in the program cannot even compile. Or when does an exception occur? All the exception occurs only when you run the program. Even if it is a compile time error or a runtime error, they will only occur when you run the program. I will come to what are compile time errors. What happens is all the errors which are occurred due to programming errors, these are called runtime errors, and their super classes runtime exception class. Okay. Now there are certain other errors, exceptions which can occur due to the bad input. For example, let's say I told you about file. You're trying to read from a file, but the file does not exist there. So if the user We don't change the program. If the user puts that file there, the program will run nicely, right? The program will run nicely. So program is recoverable from that type of error. So generally, recoverable errors are compile time errors, and when you're writing the these kind of statements, so certain APIs, they throw runtime exceptions, certain APIs throw compile time exceptions. So when I create an, let's say I'm creating file not found exception. I'm writing a program to read from a file. Say read file, and here I'm passing the file path. I'm using a file reader API. You don't have to worry about this. We will do it in next class. Say file reader is equal to new file reader. Now if you see, there is a red line coming up here. What it says that surround with try catch block. That means there is a very high chances that the input might be bad in this case. So the program does not allow you to continue. The compiler does not allow you to continue until you catch this exception. Okay, because there would be chance that you can recover from this error. So you should always put a catch block in this. So Java forces you to put a catch block here. In runtime exception, Java does not force you. Here it did not tell me, or it did not force me to catch that error, because that error might occur from any logical error. Java cannot take care of all the logical errors you are doing, right? But this is a common type of error which occurs due to bad input, right? And through which your program can recover. So Java is forcing you to put it into try catch, until then it will not compile the program. Okay, so here I have to catch the file not found exception. Okay, so this is a compile time exception. So we have seen runtime exception. What are the various runtime exception examples? We just saw arithmetic exception, null pointer exception. What else? Array index out of bounds. Negative array index, illegal argument exception. These are all runtime exceptions. The program, that means the compiler will not prompt to catch these exceptions. They occur due to bad logic in the program, and it's programmer's responsibility to catch these exceptions and do the necessary steps. Is it clear? illegal argument exception. Okay, let me see. Let's say I'm trying to pass. Okay. Okay, so I want to find illegal argument exception. I'm trying. I'm not sure. Argument exception. Okay, so public void, say check string. So I'm passing, let's say, a string, and that string is in SSN. I want to ensure that all the characters in SSN are digits. Okay, so what I can do, I can say integer dot parse int SSN, and it gives me int x is equal to integer dot parse. Okay, so I think this should go. Let's say this out x, and let me call this ex dot when I'm saying 45, it should return me 45. Right? This is returning 45. This is an integer value. Let's say I'm writing here this thing. Yeah, throws me an exception. Oh, this is number format exception. I'm sorry, like, yeah, this is number format exception. So illegal argument exception, I'm not sure. I'll try to figure it out. This number format exception. This is also a one kind of a yeah, because it was what you are doing. You are trying to convert a string to an integer, but that does not contain digits, so it cannot convert it into an integer, right? So it is a programmer responsibility to ensure that SSN is basically contains only digits. Okay, otherwise it is. So this is a small program to find out. I would be giving this in exam test also. Write a method to check whether the content of a string contains all digit values. Does not contain anything different from digit. Only permissible values are digits. So write a program. So what you have to do, you can put this into a try catch block. What you can do is try catch, and what is the exception it is throwing? Number format exception. Number format exception. Catch this, and if it comes here, let's say you are returning a boolean, and initially boolean is return value is false. So it returns true if the digits are, if the SSN contains all digits. If it does contains any other character, it should return false. Okay. So if it goes in try block, here you are returning true. Return is equal to true. And it goes to catch block, then what you have to do? Return is equal to false. Right? So it's a small program that will check whether the this argument contains digits or not. Is it clear? Okay. Okay, fine. Types of exceptions, runtime, and then we have compile time exceptions, or we call them checked exceptions. This is unchecked exceptions. Why unchecked? That means they are unchecked by the compiler, right? These are checked exceptions. That means compiler is going to prompt you if you do not catch them, right? And give me some examples of checked exceptions. So we have already seen file not found exception. Then we have SQL exception. Then IO exception, end of file exception. Okay, so these kind of exceptions are compile time or checked exceptions, and you you have to catch them before you continue with the compilation, right? Now what happens is, as you have seen, there are try and catch blocks. In the catch, in a particular code, or you can have not only one exception, you can have, there could be conditions for multiple types of exceptions also. For example, I'll give you a simple program. Let's take this program only. File reader, right? So, or I can write another method. Say find the characters in string, something like that. So I'm just writing a dummy program, and here, so let's say there is a string str is equal to null, and you have division by 0 also. So, or I can create an array. So let's create an array related exception. So int array is equal to new. This is how you create an array, right? So, and I am trying to print here this out str dot send. Let me pass the string as a argument, and I am trying to print something else also. Add say add 2. Okay. Now in this method, this is gonna throw, let's say if the str is null, this statement will throw which type of exception? Null pointer exception, right? This statement will throw, let's say I type here -2, right? Is -2 a valid index for the array? No, it's gonna again throw an exception. So same block of code is capable of throwing more than one type of exception. So your program should catch both the exceptions. Okay, so you should write the program in such a way so that you are catching both the exceptions. So you will put this into a try block, and you will put a catch. So you will first say null pointer exception E, and here you can write, string is null, and you can have another catch block, and this catch block will catch which type of exception? So this is going to throw array index of out of bound exception. And here you can say array index invalid, right? So in a statement, what I'm trying to say, in a statement, in a statement or a same block of code, you can have multiple catch blocks also. But the try is same. Try means this is the entire block which is capable of all these exceptions. And sometimes people say that we don't remember the, we do not remember the name of the exception, right? So there are so many classes. So as you will be using these, you will be remembering those classes. And there you can always use catch the, what is the super class of all the exceptions? Exception. And the exception, what is the super class of exception? Throwable, right? So either you can, even you can actually catch throwable object also. Okay. Or you can, instead of throwable, you can catch the exception object also, right? So how the program works. So let me tell you how the program works now. Let's say, let me call this method. I am calling here and I'm passing the null here. So what would happen? What should happen? When I'm passing null here, what should happen? This, it should throw the exception at this line. When it throws the exception at this line, the program should halt there. It should not go to the next line. So this line should never be executed. So let me list out something. I would say after printing length, and I would say here after printing array. So this line should never be executed. Immediately after this, since we caught the exception, it should come to this block and it should print string is null. Once it print string is null, it goes back and prints this line, right? If we don't catch the exception, what will happen? The program will stop there. It will not come to this line, right? So let's try to run this. The program ends nicely. The string is, the first string is null. I think it is coming from here. So let me just okay. String is null and the program ends nicely. So my program, it halted here. Even this is not executed, right? So now what happens? Let's say I am passing, this is a correct string. I am passing a correct string here. Now after this, it actually caught here. It is a negative array index, right? So it threw an exception and it did not, if you see this, after printing array, it was not printed here because the exception was thrown here and it was caught here and this line was printed, array index invalid. And then it went back to the calling method. And what was the calling method? This is the calling method and this line was printed. So 0 is the length of the first string. So it executed nicely. It printed the length of this string. Then it went to the next line, next statement. This is the next statement, r -2. and it threw the exception here. The exception was caught into this block. This array index valid was executed, and then it went to continue the next line of code. Right? So what happens is, at a say, even if you have multiple catch statements, only one catch statement executes. Only one catch statement will be executed at one time, because the program will not continue, right? To the, even if C -2 was already there previously also, but it was never executed because your program halted there, right? So what happens is, when it throws an object, when an object is created, when it sees that line of code, when JVM sees that line of code which throws an object, it matches with the catch statement. If it finds it, then it will go and execute the code which is written inside the catch block. If it doesn't find it, for example, let's say I remove this part. Yes, if it doesn't find it, then what happens? We already have a super class, throwable class, so it will come here. So some exception, it will come here, right? So always put a throwable or exception catch block at the end of your catch statement. First write the most specific. So what you have to do? You first have to write the exceptions which are bound to happen in your code, and then write the general. Okay. So if it matches with the specific, it will go there. If it doesn't find it, let's say there is an exception, it will anyway it will be caught here. So let's say I forgot to write the catch block for array index out of bounds. Now if I write this again, see some exception. That means it is still caught, right? No, it will not say which exception it will caught. To find that which exception it caught, so if you see this, I have created an object E, right? So you can always print the stack trace. You can say E dot print stack trace. What does that mean? Here also I can say E dot print stack trace. So in a lot of log files you will see the stack trace. Stack trace means all those 3 lines of code which we saw when the exception occurred, right? So the program will still continue, but it will print the stack trace on the console, or maybe if you want to print it on the log file or whatever. Okay, so this E.print stack trace will print it on the console. If you want to find the exact cause, so you can say E.get message. Okay, E.get message. So you can print this also. No, you can print it on the online, right? See, this is system.out. I'm printing. I'm printing on console, but you can print it on the in a file also, log file also. So if I run this again, see here, this is the message. That means the error is lies in -2, right? And this is my customized message. Let's say I want to write some message, some custom message. Okay. So here you can use E.print stack trace. So there are other also. So get cause, get localized message, get stack trace. Okay. Print stack trace. Let's say you want to print the stack trace to a print stream would be like a file. If you want to print the stack trace to a file, then you will be using print stack trace or print stack trace with the print writer. Okay. Did you get this? These are 2 different streams. I will come to the streams, like different types of streams where you can write. So I'll come to it in the next class. When we'll do file IO, then we will talk about these streams. But for you, you can say that print writer is basically a way to write on a file. Okay, so print writer API is used to write on a file. Okay, so instead of writing on the console, you are writing the stack trace onto the file, right? So as a QA, the developer code will be throwing lot of exceptions. That is the reason we take a full exception class here, because that as a QA you have to see the stack trace, you have to find the correct place where a correct line or statement which is throwing the exception. What kind of exception it is throwing? Is it recoverable exception? Is it something a logical error? So what you are looking for, logical error or a bad input error, so that your program can recover from it, right? You don't want to abruptly stop the application. You want to give a nice message. Sometimes, you know, when you click on in any application. Yesterday I was working with Shutterfly, and it is there are so many parts of that application that are not working. So it simply says you know, the search does not produce the result. So the user thinks it's something wrong at my side, but I knew that one of my candidates is working and it is still into development. That application is still into development. But see how nicely they have written. So this is called caching of exceptions. So you cache the exceptions to log into the details that why the exception occurs, so that the programmer can go and write a better code and to display an appropriate message on the console or into the web, right? Okay. Exception. So throw the exception means now why the exception, who is throwing the exception, and what condition is making you throw the exception? Your program, your logical error in the program is making you throw the exception. Automatically the exception is throw. But there is a keyword in Java called throw. You can write your own logic to throw an exception. For example, what I can do is here, let's say I can write here if str dot equals say Sam, then throw new, let's say I want to throw some exception. What I am doing here, throw clause is used to explicitly throw an exception according to your condition, right? Here I am defining the condition. If str equals Sam, please throw the exception. And I would catch the exception when you throw the exception, because my exception is caught here, it will still print this some exception. So let's try to run this. Let's create a condition where str equals Sam. So I'm passing here find char in string if you see this, the exception is thrown, and with the message, what is the message? Valid input. I created an exception object with the message valid input, right? So it threw the exception and it also caught, because it was caught here. So it threw the gave me the e.get message. It also set some exception and the program ends nicely. So I am defining throw clause. So let me write it in the note. Throw clause is used to throw the exception based on programmer's logic, or you can say to manually throw the exception, manually throw the exception, right? So your JVM is like you are not encountering, the JVM is not creating a logic to throw. You are creating your own logic, right? Right? So anytime you can create any logic to throw any kind of exception. For example, let's say file not a found exception. You are passing a parameter. Say you are passing the path here. If the path is null, you still want to throw file not found exception. So you can write here if path let's say if path is equal to null, then throw file not found exception. So how would you create? You will create an object of file not found exception, and if you want, you can pass the message here, say null path. And then, and since this is file not found exception is a compile time exception, so you have to put it into a try catch. Otherwise, your program will not compile, right? So for every compile time exception, you have to put try and catch block. Is this clear? Throw is clear or not? Here I am catching the exception. For some reason, I don't want to catch the exception here. I want to catch the exception in the calling method. So what I can do, this program, let's write another set of code. Say I'm catching file IO exception. Complete void write to a file. Right. So here I'm using the say print writer. It's an API to write onto a file, and new print writer. And let's say I'm passing the file path here. Now this program is being surrounded with a try catch or add force declaration. I don't want to catch the exception here. Maybe there are so many methods which will be showing this. Let's say in the program I have certain other operations like read from file, write from a file, append to a file, right? So I don't want to put try catch in I don't want to handle the exceptions here. I want to handle in the calling method. Let's say I'm calling it from the main method. So I want to handle the exceptions here, right? So I want to write just one code for all the method, this file handling, right? So what I can do, instead of writing here surround this catch, I would say what method, what exception is going to throw. It's going to throw file not found exception, right? So I can write here throw file not found exception. So what this means that if this exception occurs, it's not being handled here. It's being handled in the calling method. Now if you see, if I save this program here and I call this method here, ex dot write to a file, this program will not compile. Say some abc.txt. Why it is not compiled? Because since I threw the exception to the calling method, I have to put the try catch here now. But this try catch will cover all the try catches. So what happens? I'm putting I'm adding the try catch here. So here I can call. So I can call a reader file also. I can call any other, any other method which is throwing file not exception, and only in one catch I can handle, at only one piece of code I can handle all the exceptions, file not found exceptions. So let's say I write here this out, file as is not available, right? Otherwise, what I have to do? Otherwise, I would have to, handle it right to a file. Here also, I would have handled just like this. So I can remove this now, file not found exception. I can add a throw. But whenever I'm removing this, I have to add that throws clause in the method signature. What does throws clause mean? Let me summarize it again. Throws clause passes the exception object to calling method where the exception needs to be caught, right? So throw clause, I am the current method, I am not writing the try catch, I am writing the try catch is the calling method. Okay, so I am throwing the exception to the calling method, that is called throws. And not only one, similarly just like the previous example, here I had the 1, 2, 3 exceptions. So I can throw 3 exceptions also. So I can write here file not found exception, comma, exception, right? So exception is the most general. So the most general class I would be writing on the rightmost side, and the most specific I would be writing on the left side. So file not found exception is the subclass of exception, right? So subclasses I would write first and then the superclass. Okay. So what will happen? Let's say I'm giving another example. Let's talk about file not found exception. Now I want to read from this file. So there is an API called file fr.open. No, not open, .read. So I'm reading from the file. This the read throws IO exception. So what I have to do, I have to catch IO exception also. But what happens? File not and file exception is a subclass of IO exception. So if the file not found is, if the this exception is thrown, where it would go? Will it go in file not found or IO exception? It will go in file not. First, it will check for the most specific. If it, let's say, if I do not write this, then it will go to IO exception. And you should always write like this only. The most specific you should write the catch block above, and the most general you should write at the bottom. If you try to put it the other way, it will give a compilation error. It will not, what compilation error it will say? It will say the code not reachable. Because, see, let's try to do this. I am trying to put the catch block here. This is an interview question. Now what happens? Any exception will be caught here. Because IO exception will caught all the file related exceptions. So this piece of code is never reachable. So this will say this code is never reachable, right? So we always have to, the program will not compile. So always have to put the most specific at the bottom, and more specific at the top, and most general at the bottom, right? Now see, if you see this, right to us, since we threw it into the main, now I have to put it into the try catch block, and write to a file, let's say add, because it is throwing the exception also. If you see this, I threw both the exceptions, file not found and exception. So I have to catch both the exceptions in the main, file not found and the exception. I threw two exceptions, file not found and exception. So I have to catch two exceptions, file not found and exception. Whatever I'm throwing from the method, I have to catch it. Right? Okay. Now, whatever we have seen here, we have seen try, catch. There is another block of code which is called finally. Don't worry about it. Okay. What is finally block? So we have a try block. What does try block mean? Try block is the block of code capable of throwing the exception. Catch block is the code which is executed once the exception is caught with the matching object. Now my question is, let's say your program is throwing null pointer exception, and in the catch block you did not catch null pointer exception, and you do not even catch the exception or throwable. What will happen? So it will throw the exception. Since it is not caught in those three lines, it will just simply throw, because it will find the matching object. If it not find the matching object, it will simply throw. Right? The program will stop. Program will halt. So catch block is the code which is executed once the exception is caught with the matching object. Then there is another block which is called finally block. Finally block is the block which is always executed whether the exception is thrown or not. So what happens is, let me give you an example. We are writing here, if you see, we are reading from a file, right? So whenever you are doing the file handling, you are opening the file using the new operator. You are reading from a file, then you have to close the file stream. If you do not close the file stream, there would be memory leak, because your garbage collector does not close the stream, right? So you have to call the method called fr.close to close the stream. Now what happens? Assume there is some exception thrown at fr.read. It will not go to the next line. So your stream will never be closed. So in this case, we create a finally block and we ensure that this fr.close is called in finally. Because even if it goes here, then also it goes to finally. If it comes to any of the catch blocks, let's say for some reason there is an exception, then it will come to the catch block, then also it will come to this block and close. Did you understand this? So finally should be always executed last. Yes, it's always executed last. It's always written in the at the last. And it's the code which is always executed. Let's say I want to write in my log file here. This method, the read file method executed, something like this. I want to put this. So whether it is thrown an exception or not, I want to execute this and put it into my log file. So where will I put it? In the finally. So finally block is generally used to close the file handle or to close the correction pools or to put something into a log file, so you put a finally clause there. And since finally clause here, it is giving me a compilation error because FR I created in try. So the scope of FR object is within try only. So what I'll do, I'll always create it outside the try and just initialize it inside the try block so that I can access it into finally. And fr.close also throws an exception. So you can again put it into a try and catch block. Okay, and fr.close will, so you always have to check if fr is not equal to null, then only do fr.close. Otherwise, do not do. If it's already null, then we don't have to close it, right? If it's, let's say, for some reason, when you are trying to open the file, then only it is not creating the object. That means fr is still null. Then you don't have to close the screen, right? It's already closed. So you check it and then you close it. Okay. So finally block is the block of code which is always executed. Right? One last topic in exception. I know it is too much for a day, but still. Right now we have seen that these are all exception classes which are defined in java.lang, right? So different APIs might have their own exception classes, like you will be using Selenium WebDriver or something, it will have their own exception object. You can define your own exception classes also. For example, let's say I can create my exception class like this. Let's say I want to create, so there are two types of exceptions. There are compile time exception, there are runtime exception. So you can create your compile time exception also class, or you can create your runtime exception class also. So let's create our own exception class.
If you create this class, then whatever the error will be shown, can be related to this one?
Yeah. I'll show that. Bad URL exception. Say I'm creating a class bad URL exception, and I have to extend. Let's say I want to extend it. I want to make it as a compile time exception. So I have to extend with the class exception. Okay. And then I would, let's say I create a constructor, and I'm passing some message here. So I'm creating a bad URL exception. This is my own exception class, and this is extending the exception, and this is a checked exception. Checked exception. So let's come to my exception basic test. So let's say there is a string. There is a string URL string. I want to check. Say, let's say my string is www.whiteboxerase.com. Now I want to check if not of URL dot ends with say .com, then throw new bad URL exception, and you can write here say URL is not valid, and it's a compile time exception, right? So what I'll do, I have to put it into a try catch. This is a compile time exception, and here I can write here this out. You can say the please enter a valid URL. Program cannot continue. Right? Something like this. I'm just giving some kind of. So if it finds this, this is the message which will be thrown in the object, and this is your customized message. So let's try to run this. Okay. Just give me a second. Let me just put this into. Say I am writing here .co. Do you see this? This is not valid, and please enter a valid URL. Program cannot continue. So what happened here? Let me walk through the code again. I created an exception class which is extending exception. So I'm creating a checked exception or a compile time exception. Compile time exception means I have to forcibly cache it, right? And I created a constructor and I passed the, because my exception class has a constructor which uses a string as an argument. So I have to create a constructor. I'm overriding that constructor. Then what I'm doing, I'm writing my own logic. If URL ends with, if it does not end with .com, then throw this particular exception. Create an object of bad URL exception and say it is not valid. And I'm catching the exception. If this exception occurs, write this into the log file. Okay. Okay. Now if I want to create a runtime exception means you may not be putting into try catch. Then what I have to do, say I'm creating a runtime exception. Generally we do not create our own runtime exceptions because runtime exceptions are for programming errors, right? So it's better to correct the programming errors rather than catching runtime errors. So generally, if the error you think it is recoverable, then make it as a compile time exception. Otherwise, make it as runtime exception. Say I'm just writing my runtime exception. And how would I define it? The super class for this would be runtime exception. Is not. Okay, and here again you can write a constructor. Some message and all. And again, you can write your own logic when to throw it in, but you may not be, you don't need to cache it. So let's say, so for this, let's say you can simply, write any statement. So throw new my runtime exception. Something wrong. Okay, so I'm not, I'm allowed to, just run this without try and catch because this is a runtime exception. Got it? So what is the logic? When should I create my, when I'm creating my own exception, when should I create it? This is an interview question. When should I create my exception class as compile time or runtime? So your answer is if the program is recoverable from the error, then make it which type? Compile type. Compile type. Otherwise, make it runtime. So generally, we make it compile. We generally create our compile type compile time extension. Okay.